I want to use this example, which is in your example data files for GAS 2000, to illustrate the features and how to use the GAS 2000. This is an example where we have a supply point here going through a pump or compressor. There's some various demands, a couple pressure regulators, and some additional pressure, constant pressure sources or supply points. So one difference between this and the KYPipe 2000 is the number of elements we can consider. If we look at our drop down here, we can use just these elements: pressure reservoir, junction, of course, a pump compressor, a pressure regulator, loss element, and a pressure supply, which the pressure varies with how much supply we have. We can also use meters, check valves, meters in the system, and the metering capability for KYPipe 2000 will apply for gas systems. Now, if we look at the system data, we can see some additional differences. The flow units, we can use SI or English, and there's quite a wide selection of choices: pounds per second, pounds per hour, and all these other choices. We're using pounds per hour in this example. Also, the pressure, PSI gauge, absolute, pounds per square foot, and so on. We're using PSI gauge. We need an operating temperature. We either need a specific gravity, in other words, we need these 4 items, or we can use, instead of specific gravity, molecular weight, which is used in this particular problem. We can also use a gas density, and it will utilize a feature to handle a constant density instead of variable densities. If we want to analyze a real gas instead of an ideal gas, we'll have to enter the critical pressure and temperature and use this feature. Now, we do have some lookup properties, and if we access, which I'm doing now, drag this down and run this. See how this works. We can select these different elements. For example, methane. This is the one I think we're using, and these are the properties. So that's a convenient way to look up the various properties that we have to use. So if we go back to the map, we enter the data, of course the pipe data, and the node data is basically the same as we have for Pipe 2000, except that the units will be different. We have demands here. We can use demand types if we want. And so in this particular problem, we have an analysis set up where we've run the demands with various factors, increasing the demands as we go. So we run the analysis, and let's look at some of the results. It's already been run. The analysis has here, for example, is a plot of the pressure at this particular node that we had highlighted. The pressure keeps dropping off because the demand goes up. So the use of GAS 2000 is very, very similar to KYPipe 2000, and the quick start examples and the AVIs on developing models and the commands for laying out the pipes and nodes are basically the same.